Hi everyone. Just in this video, we're going to have a very quick look at using prime decomposition to simplify algebraic expressions. Just to remember, when we're talking about prime decomposition, we're talking about breaking numbers down into their prime factors, so the smallest numbers possible. So 25, that breaks down into 5 squared. 40, you can write that in numerous ways, but every time you break it down, the smallest it goes is 2 to the power of 3 times by 5. And 100 breaks down 2 to the power of 2 times by 5 squared. So these are that's what we mean when we talk about prime decomposition. So breaking numbers down into their smaller components, into their primes. Okay, let's have a look at this first one. So if you look at the 3 can't go any smaller, so we leave it alone. 6 breaks up into 2 and 3, so we do that. And 12 breaks up into 4 and 3. So 4 is 2 squared and 3. 9 breaks up into 3 squared, and 2 doesn't get any smaller. Notice that I'm switching between multiplication signs and multiplication dots. It really doesn't matter. Just pick a notation that works for you. Okay, now we expand our brackets, and we're going to also deal with those negative powers at the same time. So this first 3 here, I'm going to move that to the bottom because to make that a positive. Now the next bracket, I'm going to expand that bracket. They're all positive, so I'm going to leave them on the top. The third little term here, which is the second bracket, that's got a negative power, so I'm going to move that to the bottom. So that's going to be 2 to the 6, 3 to the 3. See, we've now got positive powers. And on the bottom, we have 2 negatives. So both of those are going to move to the top. So we're going to expand that 3, that's going to be 3 to the 8, and then 2 to the 3 on the top. Now, top with top, bottom with bottom. So we've got a 2 and a 2. 2 to the 4, 2 to the 3, that's 2 to the 7. 3 to the 4, 3 to the 8, that's 3 to the 12. And 3 to the 3, 3 to the 3, that's 3 to the 6. And 2 to the 6. Now we can simplify top with bottom. So we've got 2 to the 7 and 2 to the 6. That leaves 2 to the 1 on top. And 3 to the 12 and 3 to the 6. That leaves 3 to the 6 on the top. Done. We can write that as a multiplication. Probably not going to expand that out because 3 to the 6 is going to be huge. Okay, it works the same way when we have an example like this second one where we have pronumerals in the powers. It's exactly the same. We break it up. So 3 stays the same. 6 is going to break up into 2 and 3. 8 is going to break up into 2 cubed. And 3 stays the same. Now, expand those brackets. We don't have any negatives here, so we don't need to worry about that. Now, we've just got to be careful. With the top and top, that's going to be easy. It's just when we come to simplifying top and bottom, that's when we have to be very, very careful. So we've got 3 to the 2n and 3 to the n. So you add the powers. 2n plus n is 3n. Leave everything else the same, because there's nothing else to simplify here. Now this is different to how I would normally work a normal algebraic expression. Because of the pronumerals and the powers, to remind myself that we've got subtraction and that I don't get lost with the numbers that I've got, I'm going to actually bring all of the numbers up and do full index laws where I subtract the powers. So it's going to be 3 to the power of 3n minus n, and 2 to the power of n minus 3n. So we get 3 to the 2n and 2 to the negative 2n. The main reason I do that is so that we don't lose this negative here. Sometimes we can make little mistakes when we don't change that. So it's going to end up, I'm going to change that negative to make it a positive power. That's the correct solution. Because the powers are exactly the same, it only works because the powers are exactly the same, I can actually write it as 3 over 2 all to the power of 2n to simplify it as well. Okay guys, I hope that helped. Thanks.